Now, in this lecture, we want to trace the curve x square into y square, which is equal to a square whole times of y square minus x square. We have to trace the curve x square into y square, which is equal to a square whole times of y square minus x square. Let us just simplify it. X square into y square, which is equal to a square y square minus a square x square. Now we are replacing this to the left hand side. So it will be x square minus a square into y square, which is equal to minus a square x square, or y square plus a square. If we replace this term to this side or this term to this side, we are getting y square plus a square into x square, which is equal to a square y square. So we have uh, rearrange this equation in two ways. This is the first way and this is the second way. Okay. Now, if you want to trace this curve, we need to check the following points. The point number one is about symmetry. Now, since the power of x and power of y both are even, so the curve is symmetric about both the axes. So it is symmetric about x-axis as well as symmetric about y-axis. If we replace x by minus x or y by minus y, the equation of the curve will never change because the power of x and y both are even. So it is also symmetric about opposite quadrant, right? Which is not mentioned over here, but it is also symmetric about opposite quadrant. And it is not symmetric about line y equal to x, because if we replace x by y, if we replace x by y, and y by x, then equation of the curve will change because there is a minus sign over here. If there will be plus sign over here, then it is also symmetric about line y equal to x and line y equal to minus x. But here, since there is a minus sign present over here, so it is not symmetric about line y equal to x as well as line y equal to minus x. Now, since there is no any absolute constant term present in the curve, so the curve passes through origin. And if we see this curve, there is no any absolute constant. Each and every term contains the variable x, y. So this curve passes through origin. Now, the second question arises, if it passes through origin, then how to find the tangent at origin? So we know that tangent at origin can be obtained by equating the lowest degree term is equal to 0. So what is the lowest degree term over here? It's the first term has power 4, and this is the lowest degree term whose degree is only 2. So the a times of x square minus y square equal to 0, which implies y square, which is equal to x square, which gives us y equal to plus minus x. So we have two different tangent at origin. One is y equal to x and another is y equal to minus x. Since we are getting two different tangent, therefore the origin is known. Origin is known. Now let us try to find out the intersection with coordinate axis. From 1, we have x square y square equal to a square whole times of y square minus x square. So if you put x equal to 0 or y equal to 0, then we get the intersection with coordinate axis x axis. So we get if y equal to 0, this is 0, this is 0, right? So we are getting x equal to 0. Similarly, if we put x equal to 0, then we get the intersection with y-axis, we again get y equal to 0. So this curve only intersect the coordinate axis at only origin 0, 0. Let us try to find out the asymptotes. So parallel to x-axis, here highest power of x is x square and whose coefficient is y square plus a square. Hence, asymptotes parallel to x-axis is given by y square plus a square equal to 0. And if we simplify it, we are getting the imaginary asymptotes y equal to plus minus a. And we know that there is no meaning of imaginary asymptotes, so we cannot consider these asymptotes. Second is asymptotes parallel to y-axis. So here the highest power of y is 2. Now we are able to check over here. Highest power of y is y square. So if we write down what is the coefficient of y square, it is x square minus a square into y square. So this x square minus a square is the coefficient for y square. So let us try to equate 0. We are getting x equal to plus a and x equal to minus a. So this x equal to minus a and x equal to plus a is the asymptotes parallel to y-axis. Means if this is the y-axis, so this is the x equal to minus a, this is x equal to minus a, x equal to minus a is this, and x equal to plus a is this, and this is y-axis. So this is asymptotes means the whole curve lying between x equal to minus a to x equal to plus a. In this step the curve will lie only. Okay, let us go ahead to check about the oblique. There is no oblique asymptotes because we have the parallel asymptotes. Reason of absence from 1 we have x square minus a square whole times of y square, which is equal to minus a square x square, or if we multiply by the minus sign to whole equation, it is a square minus x square whole times of y square, which is equal to a square into x square, which gives us y square equal to a square upon x square upon a square minus x square. So if we find the value of y, which is nothing but root of a square x square is ax, and it is a minus x, a plus x, because we know that a square minus b square is a plus b and a minus b. So root over a minus x and root over a plus x. Now, this is very clear that if a minus x, now if x is less than minus a, means what about this point? If a plus x is less than 0, what it means? It means that x is less than minus a. What will happen then? This root over a plus x will be negative. A plus x will be negative, and square root of negative number is imaginary number. So the y will become imaginary. Similarly, if a minus x is also less than 0, it means that minus x is less than minus a, or if you multiply this sign by minus sign, x is greater than a. X is greater than a. X is less than minus a, then y will be imaginary. Similarly, if x is greater than a, then also y will be imaginary. So there is no part of the curve for which x is less than minus a and x is greater than plus a. Hence, the approximate shape of the curve is as follows. Now, let us try to describe one by one. Since this is origin, right? At origin, what is the tangent? There are two tangent. This is the tangent at origin y equal to x and y equal to. So this is the first tangent, the second tangent, and this is the first tangent. Now, what is the asymptotes parallel to y-axis? So this is the first asymptotes. This is the second asymptotes. Okay, and what it means? It means that if we write down that this is first tangent. let me just start from the tangent. This is the first tangent. So what is the curve? Curve is like this. And now, since this is node means what? It is a singular point. So at this point, tangent will cross the um, line. Yeah, this curve origin. Origin is the point at which the tangent is node. So node is the not it is not a normal point, it is abnormal point. So at that point, tangent curves the curve. Similarly, at this point, this is the tangent. So if we want to draw the tangent at this point, this is again we have getting the same thing. And since this line x equal to a and x equal to minus a are some tours, so therefore the curve will never intersect this straight line, this one and this one. So ultimately, if we see, the curve will only lie in the in between x equal to minus a to x equal to plus a. There is no any other part of the curve. And again, just look here, since it is symmetric about x-axis, so what is we are getting in the above side, we are getting in the downside also. Similarly, this curve is also symmetric about y-axis. So if we fold from y-axis, we are getting the same type of curve. It will be again, or if you fold it, it will cover to each other, overlap to each other. So the curve is symmetric about x-axis as well as y-axis. So this is the approximate shape of the given curve. Thank you.